Hello, this is Travis, and this is the MEC140 Intro to Robotics midterm exam. And this is the first objective. In this objective, we're using a temperature sensor to turn on a DC motor, and we're adjusting the speed of the motor using a potentiometer. In the IDE sketch, you can see I have the potentiometer declared as analog pin 0, the temperature sensor or temperature pin declared as analog pin 1. We've set up a constant integer threshold of 74, and in the void setup, we've declared that pin 9 is output, that's our DC motor. In the void loop, we have float values of voltage, degrees C, degrees F, and we have them declared as serial print. So in the serial monitor, we'll see the actual degrees that the temperature sensor is reading as it fluctuates and changes. I have an if-else statement declaring that if the degrees Fahrenheit is read by the temperature sensor is above the threshold of 74, pin 9 will go high. The speed of the motor will be determined by the potentiometer's value. The else statement says the motor will stay low if the degrees Fahrenheit read by the temperature sensor is below 74 degrees. And here you can see I have the potentiometer with the temperature sensor and a MOSFET and flyback diode in the circuit. There's the DC motor and the 9-volt battery. And the DC motor is off right now, but you can see I put my finger over the temperature sensor and making the temperature rise above 74 degrees, turning the DC motor on. And you can see there I'm adjusting the speed of the motor with the potentiometer. There it is at full blast. And there I am adjusting it, just turning it down low. And the DC motor only turns on if the temperature is above 74 degrees, read by the temperature sensor. Here you can see in the serial monitor, we're printing the values of the voltage, degrees Celsius, and degrees Fahrenheit. And you can see that degrees Fahrenheit and degrees Celsius, as well as the voltage, is rising after I put my finger over the temperature sensor. Once it's above 74 degrees, the DC motor does turn on, and the speed of the DC motor is determined by the value that is read by the potentiometer. And that's after I've taken my finger off. You see the temperature drops below 74 degrees, turning off the DC motor. In objective number 2, we're using a liquid crystal display, or LCD, to display the sentence "Hello World," as well as the potentiometer's value. In the IDE sketch, we're including a liquid crystal library. The liquid crystal, or LCD, is designated to pins 12, 11, 5, 4, 3, and 2. In the void setup, I have LCD print Hello World, so the screen should read Hello World on LCD, as well as the words pot value. And next to that, on the next line, should read the value of the potentiometer as read by the Arduino, between the values of 0 to 1023. And here's the Arduino, and here's the circuit. As you can see, I have two potentiometers connected. One is to adjust the contrast of the LCD screen. There you go, that's very bright and not so bright. And then the other potentiometer determines the value that the LCD will display. As you can see there, the halfway mark, it's at 550, 553. And if I crank it all the way up, it should get to about 1023. And here you go, the LCD is successfully displaying the words "Hello World" and pot value, as well as the actual numeric value of the potentiometer. In objective number 3, we're using the LCD again, and this time we're incorporating the temperature sensor. So you can see there I added in the void setup LCD print temperature, as well as some programming language from objective number 1. We're basically going to make this LCD screen display degrees F, or degrees Fahrenheit, and we're going to display the value that the temperature sensor is reading, and we're going to display it on the LCD as to what the temperature is that it's reading. There you go, same as before. This time we're just using the temperature sensor instead of the potentiometer. There you go, there's the temperature, 79 degrees Fahrenheit. If I put my finger on the temperature sensor, it's going up to above the 80s, and there you go. It's recording the value of the temperature in degrees Fahrenheit and displaying it on the liquid crystal display. And there it is going down. And you can see there, if I put my finger on it again, the temperature rises again. And there's the temperature dropping. And if we go back into the serial monitor like we did in objective number 1, we can once again see the values that the temperature sensor is reading displayed in the serial monitor. There's degrees Fahrenheit rising as I put my finger on the temperature sensor, and the degrees falling as I take my finger off. In objective number 4, we're using a DC motor and 2 VEX digital push buttons. When one button is pressed, the motor will go clockwise. The other button will make it go counterclockwise. In the IDE sketch, I've included the servo library. I've declared the DC motor is the servo and attached it to pin 10 in the setup. I've also attached the digital push buttons to digital pins 7 and 4, and I've included the pull-up resistor command as well. In the void loop, I have an integer pot value is equal to analog read, and I've mapped the pot value from 90 to 140, and that's for clockwise, and 0 to 90 for the other button. The second pot speed will be counterclockwise. I have the digital read of each of the statuses of the buttons, whether they're high or low. I've added if-else statement stating that if both the buttons are low, the motor will be off. If the forward push button is low or pressed, the DC motor will turn on, and it will go. The speed of the motor will be determined by the pot value, which would be between 90 and 140. And I have included an else if statement. If the other button, the reverse button, is pressed, the motor will go counterclockwise, and the speed will be determined once again by the potentiometer. The else statement is saying if none of the buttons are pressed, the motor won't turn on. And you can see here I have the setup. There's the counterclockwise button, there's the clockwise button, and using the potentiometer clockwise, and the potentiometer is controlling the speed of the motor. And if I hit the other one, again controlling the speed of the counterclockwise motion of the motor. And if I don't press any buttons, it doesn't spin. If I press both buttons, the motor turns off. Again, if I press both buttons, the motor turns off. Thank you again for watching.